So today's topic is the ROC in Z transform. So first, what do you mean by ROC? That is nothing but the region of convergence. So region means it is a part of a Z transform, and it is nothing but region of convergence. So let's define what we mean by ROC, region of convergence. So very first we should look at the definition of Z transform. The x of Z, we should recall, it is the summation limit n minus infinity to infinity x of n z raised to minus n. So from this definition we have a Z plane with imaginary part of Z, real part of Z, and the circle with a radius r. This is all about Z transform. Now, what is the significance of ROC that we should know? So, as per the definition of ROC, it is said that ROC is a set of Z values. ROC is a set of Z values for which x of Z for a given sequence is finite. So mod of x of Z is less than infinite. So we will repeat again, the ROC is a set of Z values for which the x of Z should be finite. So less than infinite means finite. It means for a given x of n, x of Z should be finite for set of Z values. So that is the region of convergence for a given sequence x of n. So ROC is the set of Z values for which x of Z less than infinite. It means this x of Z must be stopped at some finite value. It should not go to infinite, or you can say it should not be equal to infinite. So it is the condition of ROC and definition of region of convergence. So how we will see the region of convergence in this example? Let's say x of Z we get is 1 upon Z. So for that, if we put Z equal to 0, the x of Z becomes infinity. So our condition for ROC for this x of Z will be x of Z, or we can say entire Z plane, which is the whole Z plane, but we should exclude the value Z equal to 0, for which the x of Z becomes infinite. So entire Z plane excluding or except Z equal to 0. So we should not consider Z equal to 0 in the region of convergence or set of Z values in x of Z. So for this x of Z is equal to 1 upon Z, we should not consider the value Z equal to 0. Let's say another example, x of Z is equal to Z. So x of Z is equal to Z. If we put Z equal to infinity, then it will goes to infinity. So it will be the Z equal to infinity for which value? So Z equal to infinity is the ROC. So for this, the ROC is entire Z plane except Z equal to infinity. So it should not include Z equal to infinity in the region of convergence. So how to plot this ROC if we have the region of convergence? This one is the ROC1 and this one is the ROC2. So let's plot ROC1 first. So to plot ROC1 entire Z plane except Z equal to 0. So we should not include Z equal to 0 in the region of convergence, and the rest of the region of R of Z becomes the ROC for a given x of Z. So imaginary part of Z, real part of Z. So this will be the ROC1 entire Z plane except Z equal to 0. So now consider first x of Z is equal to Z entire Z plane except Z equal to infinity. So this one is the ROC2. So ROC2, let's say we have a Z plane, but we do not consider in this Z plane the Z equal to infinity, but we should have the boundary of Z equal to infinity, because we cannot go to Z infinity. So Z equal to infinity is the ROC, or we can say entire Z plane except Z equal to infinity. So Z equal to infinity is the outside of the dotted line. So this dotted box inside is the region of convergence for a given x of Z is equal to Z. So this would be the x of Z ROC for this x of Z ROC2. So this way we can plot the region of convergence of any signal. So what is the significance of ROC? The very first is it can comment, or ROC can comment on the stability of LTI system when the LTI system is in under analysis. And the secondly, we can also comment on signals, that the signals representation or the scope of signal in time domain. For example, the signal could be causal or anti-causal, or say combination of both, causal as well as anti-causal. We say both-sided. Causal means right-sided, anti-causal is left-sided sequences. So we can easily comment on the ROC by ROC, the stability of LTI system, signals in time domain, say causal, anti-causal, both-sided, and so on. So these are the significance of ROC along with the x of Z. So only x of Z is not enough to comment on any signal or stability criteria of LTI system. So we should have, or we have to calculate the ROC of the same x of Z, for which we can have the awareness of stability of LTI system as well as signals in time domain representation like causal, anti-causal, and both-sided. Okay. So now we will see the importance of ROC, or there are some properties of ROC we should consider in the next session. Say it is known as property of ROC. Region of convergence has some significant properties for which we should consider the importance of ROC in Z transform. So let's begin. Very first point is the ROC is a ring set. ROC always have a ring set nature. For example, like this. The ROC is a ring set region, or ROC is a ring. That is the first property, but we need to consider the region, that the ROC is a ring, but it is always centered at origin. Means At the origin with a radius r, the ROC is always centered at origin in a ring shape. Second important parameter, ROC cannot contain any pole. If we say poles and zeros, so ROC cannot contain any pole, but it should contain any zeros of our LDA system analysis. Third important property, ROC of x of z includes the unit circle if ROC, region of convergence, includes the unit circle with radius 1 within the ROC, then the Fourier transform DTFT is valid, or it can be calculated for given x of n. If ROC covers the unit circle with radius 1, then its Fourier transform is valid for given x of n. It is the third property of ROC. Next important property is the ROC must be a connected region. So whatever we see, the ROC must be connected. It means we cannot plot ROC like this. ROC cannot be like non-connected region. This is totally wrong. We should not draw ROC like this. ROC always has connected region. The next important property, for a finite duration sequence, ROC is for a finite duration sequence. The ROC is entire Z plane excluding Z equal to 0 and Z equal to infinity. For ROC with a finite duration sequence, entire Z plane excluding Z equal to 0 and Z equal to infinite. It means if the ROC excludes Z equal to 0 or Z equal to infinite, it is sure that the given sequence is always finite duration. The given sequence is of finite duration. So these are the most primary properties of ROC, and the final one is for infinite duration sequence. Has the three conditions. If the given signal is causal with infinite duration, then the ROC is exterior part of circle with radius alpha. So ROC would be, if it is the exterior part of circle alpha, then the ROC is look like this. This is the ROC of causal sequence. ROC is exterior part of circle with alpha radius. Same way, if it is anti-causal, then ROC is the interior part of circle with radius alpha. So alpha would be anything depending on the input of sequence. So it is the interior part of the unit circle. So in other words, we can say over here the Z or the values of Z is greater than alpha, and over here the values of Z will be less than alpha. The alpha depends on the input sequence. If the third condition, if it is the combination of both the sequence, say both sided sequence, So then the ROC is a ring with intersection of radius alpha 1 and alpha 2, which is the radius of causal sequence as well as anti-causal sequence. So the ROC would be a ring with radius alpha 1, alpha 2 with the different conditions. So this would be the ROC of both sided sequence. So these are the important properties of ROC. So revise it. The very first thing we need to remember is ROC is a ring which is centered at origin. ROC never contain any pole, means if this region is the region of convergence for x of z, then this region will never have any poles, but it should have zeros. Third important property is if the ROC contains the unit circle of the Z transform or Z domain, then the Fourier transform is valid for a given x of n, for a given sequence x of n. Then the ROC must be a connected region. We cannot plot ROC with a non-connected region like this. This is the wrong property of ROC. Finite duration sequence. For a finite duration sequence, ROC is the entire Z plan excluding Z equal to 0 and Z equal to infinity. It means if the ROC has no 0 and no infinity values, then the given sequence is always finite duration. But for an infinite duration sequence, we have three conditions. For a causal sequence, ROC is the exterior part of circle with radius alpha. Alpha depends on the input sequence x of n. Same way, we can also say mod z is greater than alpha. Anti-causal sequence, the ROC is interior part of circle with radius alpha. It looks like this. It is also said mod z is less than alpha. So the alpha radius and interior part, all the set of z value is the region of convergence or anti-causal sequence. If it is both sided sequence, then the ROC is a ring set with intersection of alpha 1 and alpha 2 radius. Then alpha 1 and alpha 2 radius are the anti-causal radius and causal radius respectively. The intersection point depends on the three conditions. If alpha 1 is less than alpha 2, alpha 1 is greater than alpha 2, and alpha 1 is equal to alpha 2. For example, if alpha 1 is less than alpha 2, then this is the intersection point of this ROC. If alpha 1 is equal to alpha 2, then the both radius is equal. So it is the ROC is the periphery of this circle with alpha 1 is equal to alpha 2 radius. So it is all about properties of ROC, and then now we will see in next lecture the importance of ROC in our example of Z transform. So we will see the examples on Z transform by including the region of convergence and what is the significance of ROC will strike on the examples of Z transform.